Hello my dear children, or my dear viewers. So I'm going to discuss the 2024 May Unit 2 Physics paper of IEL Pearson Edexcel. Okay, so before we start, I would tell you something. If you need any support for tutoring for physics, chemistry or mathematics of IGCSE or IEL, you can contact me on +9477375557. Right. Okay, so we'll move on to the MCQ questions first. The temperature of a thermistor and the temperature of a metal wire are increased. Which row of the table gives the changes in resistance of the thermistor and the metal wire as the temperature is increased? When you know that when the temperature increases, conductors resistance increases and semiconductors resistance decreases. So with that understanding, you can go to the answer of this as resistance of the thermistor would decrease and resistance of metal wire would increase. Right, we'll try to move to the next question. The battery of the circuit shows as an negligible internal resistance. Resistor R1 and resistor R2 are identical. So whether R1 and R2 identical, whatever it is, R1 and 3.3 voltage shown resistor are connected in series. So the resistance of this, the voltage of this has to be 10 minus 3.3. I'll write it on the other screen so that you would understand better. 10 minus 3.3, which is the answer. Question number 3. The diagram shows a ray of light incident at a boundary between oil and water. The refractive index of water is 1.33. Which of the following expression gives the refractive index of the oil? So understanding the Snell's law, we can do it this way. N1 sin theta 1 equals N2 sin theta 2. So N1 is oil. I write it as O. Sin theta 1. So angle here is shown as 15 degrees. Sin 15 equals N2 is the refractive index of water, which is 1.33, into angle inside water will be 17. So sin 17. So I get refractive index of oil as 1.33 into sin 17 divided by sin 15. So 1.33 into sin 17 divided by sin 15. So we see the answer for question number 3 as answer B. We'll try to move to the next question. Which of the following is evidence that electrons can behave like waves? So electrons are attracted towards positive charge objects. Electrons can be absorbed photons and move between energy levels in an atom. Electrons can be diffracted when passing through a thin sheet of graphite. Electrons can be released by photons in the photoelectric effect. So we know wave properties as I'm noting down here: reflection, refraction, diffraction, interference, or superposition, polarization. Polarization only occurs on transverse waves. So we see the answer diffraction here. So the answer has to be Answer C. Alright, we move to the next question. The circuit includes a cell with internal resistance 0.5. So, which of the following expressions gives the EMF in volts of the cell? So, we have to apply the equations. We'll apply E equals E minus IR. So, E is 1.2. E is the EMF of the battery, what we not know. Current is unknown. The internal resistance is 0.5. So, I can write with the use of E equals IR, I is equal to V of R. So with that understanding, I can substitute I as the voltage is 1.2 into 0.5 and the resistance as 6. So taking this variable to the other side of the equation, I get E equals 1.2 plus 1.2 into 0.5 over 6, which is answer C. Move to the next question. Question number 6. Which of the following describes threshold frequency? The frequency of light that causes photoelectrons to have maximum kinetic energy. No, that's obviously wrong. Frequency of light emitted when excited electrons fall to the ground state. No. The minimum frequency of light that can cause an electron to leave the surface. The maximum frequency of light which excites an electron in the ground state. The answer is minimum frequency. So the answer is C. Minimum frequency of light that causes an electron to leave the surface. With the theory of what you have learned about threshold frequency, you know it. Okay. Move to the next question. The diagram shows part of an electrical circuit. Which of the following expression gives the total resistance in ohms between X and Y? That means they are asking the combined resistance of the whole circuit. Right? So we'll try to do a calculation on that. So 2 and 3, the combined resistance is 2 plus 3, which is equal to 5. But they are not giving the simplified answer, so they are giving with 2, 3, 4 and 6. So we'll go on with that. So the combined resistance is of this 2 plus 3 and the 4 will be 1 over R equals 1 over 2 plus 3 plus 1 over 4. So R will be equals to 1 over 1 over 2 plus 3 plus 1 over 4. So then afterwards, to this setup, what you get the resistance here, to that you have 6 ohm resistor connected in series, right? So then R is equals to 6 plus this whole thing, 1 over 2 plus 3 plus 1 over, we'll see which answer is 6. On the top is this answer and this answer, and yes, the answer expected as we have highlighted here will be answer B. Next question. Moving on to question number 8. There's a tension T in a string of length L. Uh, when the string is displaced and released, waves move on a string with a speed v. A string of length 2L has the same diameter and is made from the same material. The tension in the string is 2T, which the following expression gives the speed of waves on the string of length 2L. So, even though the length has increased and the diameter is the same and is made of the same material, so we know the equation to find the uh, wave speed on a string is V equals root T over mu. Mu is the mass per unit length. Thicker string will have a higher mass per unit length. Thinner string will have a smaller mass per unit length. So T is the tension provided. So the length has no effect and diameter has no effect. So substituting to the two scenarios, initially we'll assume the speed is V as what they say on the question. The tension provided is T and mass per unit length as mu. I like that equation number one. And second instance, the tension is 2T as what they say. The mass per unit length is the same because they say it's the same material. I like this as equation number 2. If I divide the second equation by the first, I get V dash over V equals to 2T over mu into T over mu square root. So, sorry, I made a small mistake. It's mu over T. So this T and T get cancelled off, mu and mu get cancelled off. I get V dash is equals to root 2 V. So the answer is answer C. Right. Moving on to the next question. A student connects the circuit shown. The resistors all have fixed, they have different resistances. Which of the following expressions gives us current in amperes in resistor R? So I can find the current here. Current here will be I will be equals to V of R, which is 1.4 divided by 4.7. So current passes to this path and then gets split into this path and this path. So um, if I write this as I1 and this one as I2 and this as I3, I can say I1 equals I2 plus I3. So I1 is 1.4 over 4.7. I2 is what we not know. I3 is given here as 0.13. So taking this variable to the other side, I guess I2 equals 1.4 divided by 4.7 minus 0.13, which is answer A, isn't it? Answer A. Going to the next question. Question number 10. Light of uh, wavelength lambda traveling at speed c is incident on a metal surface. Photoelectrons are emitted from the surface with a maximum kinetic energy half mv squared max. The graph shows the relationship between 1 over lambda and half mv squared. Which of the following shows the gradient of the graph can which the following shows how the gradient of the graph can be used to determine the Planck's constant. Right. We'll start with the basic equation and see how we go with that. You know HF equals phi plus K max. That's Einstein's photoelectric equation. So as I have a lambda, I'll rearrange the equation hc over lambda, whereas v equals f lambda. For electromagnetic waves, the speed is c equals f lambda. So instead of f, I can write c over lambda. So which c over lambda is what I wrote here instead of the frequency. So hc over lambda is equals to 5 plus k max. Instead of k max, I can write half mv squared max, right? So we'll make 1 over lambda the variable on the y-axis, so we can get the other variables to the other side. So when I keep 1 over lambda there, I have a hc is equals to 5 plus half mv squared max. When I take the hc to the other side, this whole thing to the other side, I get 1 over lambda equals 5 over hc plus half mv squared max over hc. So here the variable what we have is lambda and half mv square. So this is a variable and this is also a variable. Understanding that, I can write this equation in this manner. If y equals 1 over lambda, I can write 1 over hc into half mv square max plus 5 over hc. So we'll write this as 1 over lambda as it is, how it works. So 1 over lambda, I'll take it to the y-axis, half mv squared is there on the x-axis. So 1 over hc will be just the gradient, and 5 over hc will be as an intercept. 5, h and c are constants. So here also h and c are constants. Only variables are lambda and half mv squared. So we have taken the y variable as 1 over lambda and x variable as half mv squared max. So they are asking how the gradient of the graph. So if I talk about the gradient will be equals to 1 over hc. To find the h value, I'll take h there and take m here. So h is equal to 1 over mc. That means it will be equals to 1 over gradient into the value of c. So we have that answer on answer B. So I hope you understood how we discussed the first 10 MCQs.